This video, we're going to prove the following fact. If P and Q are distinct primes, then P to the Q minus 1 plus Q to the P minus 1 is congruent to the number 1 modulo PQ. If you like seeing mathematical proofs, you should seriously consider subscribing to my channel, as that's all we do on this channel, mathematical proofs. No matter which video you click on, you'll see a mathematical proof. Now, when it comes to this theorem, here I see Fermat's little theorem, and here I see Fermat's little theorem. We know that P does not divide Q. So thinking of this as A, and P is prime, this tells us A to the P minus 1 is congruent to 1 mod P. Also, Q does not divide P. Thinking of that as A and this as the prime, this tells me that A to the prime minus 1 is congruent to the number 1 mod Q. Okay, so we have this here, and there's a video where I proved the following. It turns out that this product, Q to the P minus 1 times 1, plus that product, P to the Q minus 1 times 1, is equal to this product plus that product. It is equal to Q to the P minus 1 times P to the Q minus 1 plus 1 modulo PQ. Okay, so that product is clearly P to the Q minus 1 plus that product is P to the Q minus 1. Now, since P is prime, that means P is at least 2. If I take away 1 from P, P is at least 1. Same exact argument for the prime Q. It's 2 or more. If I take away 1, Q is at least 1. That is, this does have a factor of Q. It doesn't have to be. I mean, for example, if P minus 1 was 0, this is 1. It's not a factor of Q. But P minus 1 is 1 or more. This does have a factor of Q. Same argument here. This has a factor of P because the power, that should say Q minus 1. Q minus 1 is at least 1. And modulo P, that's 0. So it equals to 1 mod PQ. And that's exactly what I was asked to prove. I proved it. The theorem is done. I do want to make one comment though. You should make somehow maybe include this. This shows that I thought this was just side work, but maybe it needs to be shown because you need to show that this power is at least 1. This power is at least 1. Okay, it didn't have to be. It could have been -3. But it's at least 1. So what happens is that QP or PQ does divide this. It did, that should be a P. It didn't have to divide this if this were 0. Q times P does not divide P to any power. It doesn't divide P to any power. Okay? But since these powers are both positive, we're okay. PQ or QP does divide that. That was the whole thing in this proof. If you like seeing mathematical proofs, like the one that shows that if you have what's in here, that this product plus that product is congruent to this product plus that product mod PQ, subscribe to my channel. That video is there. See you guys in the next video. Please click the like button, leave a comment, watch and learn.